So in this screencast, what I've been showing here is what I took was, so this is essentially from air to glass transmission. As you can see, it's it's 96% transmission, but there is 0.04 reflection. And as you can, and that's denoted here, left one. So from the first layer, it's reflecting 4%, and no matter, and this is wavelength, regardless of what the wavelength is, it's always going to be that. Where that changes though is when we put multiple layers of anti-reflective coating. So we've got a layer of with an N of 1.6, an N of 2.1. And then the thickness is 550 nanometers over 4. And the thickness of the initial layer and the last layer obviously don't matter. And we can see we have a dip, and then we have and then it curves back up. The curious part here is this region right in here where it goes negative. I don't know how to interpret that. So that'd be interesting if you could advise me on how that, why that happens. As we add in more layers, we see more action, or we have different levels of reflectance at different wavelengths. So here we go this would be 4, 1, 2, 3, 4. So there's 2 sets of coatings, and we can see we have 2 peaks, and then we've got 3 troughs here between 400 and 700 nanometers. So clearly we're not getting, interestingly, well, right about here, same spot, about 510, 20, 30 nanometers we're getting, where we're getting a minimum. And then I did 4, and once again, that same spot we're getting a minimum. For all these other wavelengths, the graph is going in just crazy directions. Now I tried, as you can see, let me move this over to show you that it's supposed to be running here, see? Adding in even more layers, and it's just not doing it. It's been calculating at this now for about 10 minutes, so I think I'm going to actually abort that function, so let me do that. Abort. And it just, at this point, Mathematica isn't cooperating. But as we can see, the more layers we put in, the weirder the function graph becomes. Anywhere from a straight solid line to more and more peaks and troughs.